Hello students, today we'll be starting with the first problem based on rotational dynamics. Now the question says a wheel is making revolutions about its axis with uniform angular acceleration. Starting from rest, it reaches 100 revolution per second in 4 seconds. Find the angular acceleration. Find the angle rotated during these 4 seconds. So with this, we'll start with the data. So what is the data? The very first, about its axis, and it starts from rest. So if it is starting from rest, here we'll take omega naught equals to 0. Now why omega naught? Omega naught represents the initial velocity in an angular form, as this whole problem is based on angular part or a rotational part, hence we are taking an angular velocity. It reaches 100 revolution per second. When you see revolution per second is a unit of frequency, which is also to be said in common terms n. So the n is 100 revolution per second. If I want to convert this in the terms of omega, then I'll be writing 2 pi n. 2 pi, if it would be revolution per minute, then I would have taken here 2 pi n by 60, but here it is only revolution per second, hence we are taking only 2 pi n. So if we'll multiply this 2 pi n, this will give me 200 pi, and that the unit is radian per seconds. Now after that, in 4 seconds means the time is 4 seconds. Now here we have to find out angular acceleration. Angular acceleration is denoted in the terms of alpha. What is the formula of angular acceleration? Change in velocity with respect to time. Omega minus omega naught. Omega naught is the initial velocity, omega is the final velocity. Omega minus omega naught upon t equals to alpha. So here omega is your 200 pi as it is mentioned, minus omega naught is 0 as it is mentioned here, divide by t. So the t is 4 seconds. That is your alpha, which gives me a value is 50 pi. The unit will be radian per second square. Now radian per second square. In this, if I need the value in the terms of revolution per second square, then there is an option that since 1 radian per second square is equivalent to 1 by 2 pi times of revolution per second square. So if this is the condition, then alpha can be written as 50 pi divided by 2 times of pi, where pi got cancelled, and if this will be divided, it becomes 25, and that becomes revolution per second square. That is your alpha value, which is angular acceleration. Now if I talk about the angle rotated during these 4 seconds, so in that case, that is theta, we have to find out the angle rotation theta. So theta is equals to omega naught t plus half alpha t square. Now how we got this formula? It is s is equals to ut plus half at square, which is in angular form written in this way. S is written by theta, u is written by omega naught, a is written by alpha. So this is the kinematical equation in the terms of angular format. Here omega naught was 0 plus half omega naught into t, the whole becomes 0 because omega naught is 0, half alpha, the alpha value what we got it here is 25 revolution per second square or 50. The answer, if you need it in radian, then you'd have to substitute this. If you need in the terms of revolution, you have to substitute it this. But theta, as it is not in the terms of revolution, it is always in radian, so you have to put this value. So this is your 50 pi, and the time taken is your 4 seconds, that is square terms. So theta is equals to, if you'll calculate this whole term, you'll be getting 400 pi, and the unit of it will be radian. This theta is 400 pi of radian, whereas alpha here is 25 revolution per second square. With this, we have completed this problem. Thank you.